The story of Neanderthals has always been told as a Western tale. They were the cold-adapted hunters of Europe, the stocky inhabitants of Ice Age France and Germany, eventually pushed aside by a wave of modern humans expanding from Africa. China, in that narrative, belonged to other actors: archaic Asian hominins, Denisovans, and later modern East Asians. Yet the deeper the fossil record is examined, and the more complex the genetic data becomes, the harder it is to maintain clean continental boundaries. An alternative possibility has been growing quietly in the margins of debate, that during the last interglacial, Neanderthals expanded far to the east into northern China, interacting with and perhaps partially replacing Denisovan populations, and that this eastern movement helps explain the hybrid skulls, unusual tool assemblages, and distinctive genetic signals seen in East Asia today. The foundation of this hypothesis lies not in imagination, but in geography. Neanderthals are no longer confined to Western Europe. Their confirmed range extends deep into Eurasia, including southern Siberia. The fossils and genomes from Denisova Cave and Chagirskaya Cave demonstrate that Neanderthals occupied the Altai Mountains thousands of kilometers east of France. These eastern Neanderthals were not marginal stragglers. Genomic data suggests they were part of dynamic populations moving across steppe corridors. During warm periods, especially marine isotope stage 5e around 130,000 to 115,000 years ago, Eurasia was not a frozen barrier, but a vast interconnected mosaic of forests and grasslands stretching from Western Europe to northern China. In such conditions, the idea that Neanderthals halted permanently at the Altai becomes less certain. The last interglacial was a time of expansion. Sea levels rose, climates moderated, and ecological zones shifted northward. Central Asia transformed into a habitable corridor, linking Western Eurasia to the eastern plains. If Neanderthals could adapt to glacial Europe and continental Siberia, there is no obvious ecological reason they could not move further east during a warm phase. The steppe belt, leading toward Mongolia and northern China, would have offered familiar prey species, open landscapes and river systems. In this view, the Altai was not the eastern frontier, but a staging ground. At the same time, East Asia was not empty. Denisovans, identified genetically before they were understood anatomically, appear to have been widespread across the region. The Xiaohe mandible from the Tibetan plateau, identified through protein analysis, suggests Denisovan presence at high altitudes. Modern populations in Southeast Asia and Oceania carry significant Denisovan ancestry, indicating a broad geographic footprint. But Denisovans are known primarily through genetics, not through a well-defined suite of skeletal traits. This ambiguity leaves room for reconsideration of several Chinese fossils that do not fit neatly into existing categories. Take the crania from the Xuchang fossil site, dated roughly to 125,000 to 100,000 years ago. These skulls possess large brain volumes comparable to Neanderthals and display thick cranial vaults and occipital features that some researchers have described as Neanderthal-like. Yet they lack the full facial architecture typical of classic European Neanderthals. They are mosaics, neither comfortably Denisovan nor straightforwardly Homo sapiens. In the standard interpretation, such fossils represent regional archaic continuity in East Asia. But if Neanderthals moved east during the last interglacial, encountering Denisovan populations already present, hybridization becomes plausible. The resulting skulls would not replicate European Neanderthals exactly, they would blend traits. This blending may explain why several Chinese middle-late Pleistocene fossils appear transitional or composite. Rather than viewing them as isolated archaic Asians, they could represent contact zones. If Neanderthals expanded eastward and interbred with Denisovans, the skeletal result would be variability, robust vaults, large brains, but facial configurations reflecting mixed ancestry. Such hybridization would complicate taxonomy, precisely as we see in the fossil record. Another piece of the puzzle comes from the presence of early Homo sapiens remains in southern China during broadly overlapping time windows. Sites such as Fuyan Cave and Lunar Cave have yielded teeth and fragmentary remains attributed to anatomically modern humans, with some proposed dates extending back beyond 80,000 years. While the chronology and stratigraphic integrity of these sites remain debated, their existence raises a provocative possibility that by the late stages of the last interglacial and into the early glacial phases, southern China may already have hosted Homo sapiens populations. If Neanderthal-derived groups occupied parts of northern China and Denisovan-related populations were distributed across interior and highland regions, then East Asia was not a single-species landscape, but a convergence zone. In this scenario, southern China becomes a meeting ground where incoming or expanding Homo sapiens populations encountered resident archaic groups to the north and west. Rather than a clean, one-directional replacement, the picture becomes one of geographic layering. Neanderthal expansions pressing eastward, Denisovans holding ecological strongholds, and Homo sapiens appearing in the south. Three populations converging within the same continental arena. Tool industries offer another layer of evidence. Eastern Neanderthals in Siberia produced Mikokian-like assemblages and complex prepared core technologies. Meanwhile, parts of northern China show Middle Paleolithic industries that differ from both classic European Mousterian and earlier East Asian traditions. The persistence of so-called simple core and flake technologies in China has long puzzled researchers, but localized technological blends could reflect interaction between populations with different tool traditions. If Neanderthals introduced certain prepared core strategies into northern China, these may have merged with local Denisovan or archaic practices, generating hybrid toolkits rather than wholesale replacement. Genetics adds further intrigue. Modern East Asians possess slightly higher proportions of Neanderthal ancestry than Europeans. This has traditionally been explained as either dilution in Europe through later gene flow or as evidence of a second pulse of Neanderthal admixture somewhere in Eurasia after modern humans arrived from the eastern Mediterranean. The location of that second pulse remains debated. If Neanderthals were present in parts of East Asia around 50,000 years ago, then admixture could have occurred locally in China or nearby regions rather than exclusively in the Near East. This would naturally result in elevated Neanderthal ancestry in East Asian populations without requiring complex back-migration scenarios. Moreover, the Neanderthal genetic segments in East Asians are not identical to those in Europeans. Some studies suggest multiple admixture events with different Neanderthal populations. An Eastern Neanderthal group, distinct from Western European populations, would fit this pattern. The Altai Neanderthal genome already demonstrates deep divergence within Neanderthals themselves. If related groups extended into northern China, they could have contributed unique genetic variants to modern East Asians. One of the most compelling pieces of indirect evidence for Neanderthal movement into Denisovan territory is the existence of hybrid individuals. The Denisova cave yielded a first-generation hybrid with a Neanderthal mother and a Denisovan father. This single individual proves that these populations overlapped geographically and temporally in Siberia. If such mixing occurred in the Altai, why assume it stopped there? Population boundaries in the Pleistocene were likely fluid, shifting with climate and resource availability. An interglacial expansion could have pushed Neanderthals into deeper East Asia, where Denisovans were already established. In such a scenario, competition and interbreeding would both be expected outcomes. The idea of replacement need not imply dramatic battles. Ecological competition alone can shift population distributions. Neanderthals may have had technological or demographic advantages in certain environments, allowing them to expand eastward. Denisovans, in turn, may have retreated southward or into highland refugia, such as the Tibetan Plateau. Over time, hybrid populations could have stabilized in northern China, producing the mosaic fossils we now struggle to classify. By 50,000 years ago, modern humans were entering East Asia in large numbers from South Eurasia. Archaeological sites across northern China and Mongolia show early Homo sapiens presence around this time. If eastern Neanderthal populations persisted there, modern humans would have encountered them locally. Interbreeding in this eastern zone would generate genetic signals distinct from earlier admixture events in West Asia. This could help explain the complex layering of archaic ancestry in East Asian genomes, including both Neanderthal and Denisovan components. Importantly, this hypothesis does not require Neanderthals to have conquered all of China. Even partial occupation of northern regions would suffice. The vastness of East Asia allows for patchwork settlement patterns. Northern steppe and forest steppe environments might have hosted Neanderthal-derived populations, while southern China remained dominated by Denisovan-related groups. Such regional differentiation would align with genetic evidence showing multiple Denisovan introgression pulses into different modern populations. Critics rightly note the absence of unequivocal Neanderthal fossils from China. Yet absence of evidence is not evidence of absence, especially in a fossil record as incomplete as that of Pleistocene Asia. Many Chinese fossils remain fragmentary or contested in classification. Without ancient DNA from these specimens, their precise relationships remain unresolved. Proteomic analysis, as demonstrated with the Xiaohe mandible, has already reshaped understanding once before. Similar methods applied to other Chinese fossils could reveal unexpected affinities. There's also the question of morphology. Neanderthals are often defined by a constellation of traits: midfacial prognathism, occipital buns, retromolar gaps, and robust postcranial skeletons. But these traits vary even within Europe. Eastern Neanderthals in Siberia exhibit some differences from Western individuals. Hybridization with Denisovans would likely dilute or modify certain features. Therefore, the expectation that Chinese Neanderthal-derived fossils should look identical to La Chapelle-aux-Saints may be unrealistic. Evolutionary processes operating at the margins of ranges tend to produce variation. When genetics, climate reconstruction, and fossil mosaics are considered together, the scenario of Neanderthal expansion into China during the last interglacial becomes at least biologically plausible. It offers an integrated explanation for hybrid skull morphologies, unusual tool assemblages, and the layered archaic ancestry of modern East Asians. It situates East Asia not as an isolated evolutionary theatre, but as part of a broader Eurasian network in which populations moved, met, mixed, and sometimes replaced one another. This model also reframes Denisovans not as solitary Eastern inhabitants, but as participants in a shifting balance of power across Eurasia. Rather than a static map with fixed territories, Pleistocene Eurasia becomes dynamic. During glacial phases, populations contracted into refugia. During interglacials, they expanded and overlapped. The last interglacial, with its open corridors, would have been an ideal time for such movements. Ultimately, the hypothesis that Neanderthals invaded parts of China and interacted extensively with Denisovans and later with Homo sapiens remains provisional. It awaits stronger fossil and genetic confirmation. Yet it is grounded in known patterns. Neanderthals reached Siberia. Denisovans overlapped with them. East Asian genomes record complex archaic admixture. And Chinese fossils display mosaic features difficult to classify under simpler models. As new techniques unlock biomolecular data from Asian fossils, the map of human evolution may grow more intricate. If future discoveries confirm Neanderthal presence deeper in East Asia, the traditional West-centered narrative will need revision. China would no longer be viewed solely as Denisovan or archaic Asian territory, but as a contested frontier where Neanderthals, Denisovans, and modern humans met. In that frontier zone, hybrid skulls would not be anomalies, but expected outcomes. Tool traditions would not fit tidy typologies, but reflect blended knowledge systems. And modern genetics would record not a single admixture event, but a tapestry woven across thousands of kilometers and tens of thousands of years. Whether or not the full eastern expansion of Neanderthals is ultimately confirmed, the growing complexity of the evidence already points toward a Pleistocene world defined less by isolation and more by movement. A world in which the boundaries between populations were permeable, and in which China may have played a far more central role in Neanderthal history than once imagined. Thanks for watching.